In today's lesson, we'll be expanding upon what we learned in our previous lesson, which was about solving quadratic equations. In our first example, we're given a rectangle which has dimensions 3x plus 1 and 2x minus 5. Its area is 1,150 square centimeters. What are its dimensions? The first thing you should do is do a rough sketch if a diagram is not provided. As you can see, the diagram is provided, so that makes life a lot easier for us. Let's highlight some key pieces of information. We know that the length is 3x plus 1. The width is 2x minus 5. Now, just by looking at these two binomials, it might be pretty difficult to determine what is the width and what is the length. Doesn't really matter at this point. We also know that the area is 1,150 square centimeters. We all know what the area of a rectangle equation is, and the equation is area is equal to length multiplied by width. You'll notice that I'm using a handwritten L instead of a printed L. The reason is a printed L sometimes can be confused for a number 1. So at this point, I'm going to substitute in my known values. I know the area is 1,150. I know the length is 3x plus 1. Make sure you put that in brackets. And the width is 2x minus 5. At this point, you'll notice that I have a binomial multiplying another binomial. You should use the FOIL technique. So you will multiply the first terms, the outer terms, the inner terms, and then the last terms. So let's go ahead and expand that. The 1,150 stays exactly the same. I have 3x multiplied by 2x, which is 6x squared. 3x multiplied by negative 5, which is negative 15x. I have positive 1 multiplied by 2x, which is positive 2x. And then I have positive 1 multiplied by negative 5, which is negative 5. At this point, you should identify your like terms. 1,150 is a like term to negative 5, and negative 15x and positive 2x are like terms. We're going to collect these like terms one step at a time. Let's collect our negative 15x and positive 2x terms. So right now, the 1,150 stays the same, the 6x squared stays the same, negative 15x plus 2x is negative 13x, and the negative 5 stays the same right now. Let's collect our 1,150 and negative 5. In order to do that, you need to move the 1,150. So we're going to do the opposite operation, which is subtraction. So I'm going to subtract 1,150 from both sides. If you can do that in your head, go ahead. So that cancels out. That becomes a 0. And you have 6x squared minus 13x minus 1,155. You'll notice that we've just created a quadratic expression. I'm going to continue the work on the next slide. In part A, we determined the quadratic expression, which was 0 equals 6x squared minus 13x minus 1,155. Keep in mind that we want to figure out the value of x. Now, what exactly does that mean? That means we need to find the value of the x-intercept, and you already know how to do that. We're going to do that through factoring. So take a close look at the numbers here. We have a positive 6, a negative 13, and a negative 1,155. Is there a greatest common factor among these three numbers? The answer you should come up with is no. There is no greatest common factor. Therefore, we have a situation where we have a quadratic expression where a is not equal to 1. That means we have to find two numbers which add up to negative 13, and we have to find two numbers when multiplied together give us the product of positive 6 and negative 1,155. Now, without even simplifying this, you should be able to recognize that this is a very difficult question. I'm going to give you the answers to this, but there is an easier way of doing this, which you will learn later in the unit. So these two numbers happen to be negative 90 and positive 77. Using these two terms, we are going to break up this center term. So that gives us 0 equals 6x squared minus 90x plus 77x minus 1155. So we're going to group factor these first two terms, and we're going to group factor the last two terms, which means we're looking for a monomial common factor. That happens to be 6x. That leaves us x and negative 15. So again, let's find a monomial common factor for the last two terms, and that is going to be positive 77, which leaves us x and negative 15. Remember, you want these two binomials exactly the same. So in our last step, we are going to do some binomial common factoring. So I'm going to take out the x minus 15, which leaves us 6x plus 77. We know that the product of this binomial and this binomial is 0. So that means either x minus 15 is equal to 0, or 6x plus 77 is equal to 0, or both of them are equal to 0. So let's go ahead and do that work. So I'm going to say x minus 15 is equal to 0, or 6x plus 77 is equal to 0. Now at this point, all you need to do is isolate x and solve for x. I'm going to skip some of the steps. So over here, x is equal to 15. And over here, x is equal to negative 77 divided by 6. Now at this point, you need to take a step back and see which value makes sense in real life. So x could either be equal to 15 or it could be equal to negative 77 over 6. Well, since we're talking about dimensions of a rectangle, the dimensions of a rectangle can't be negative in real life. It just doesn't make any sense. So we're going to disregard this value of x, and x equals 15 makes more sense in the context of our question. So I'm going to be doing all the rest of the work in part C. Since we now know the value of x, we can go ahead and substitute that in to find our length and width. Let's start with our length. Our length is 3x plus 1. I'm going to say sub x is equal to 15. So instead of x, I'm going to replace it with 15, and I'm going to add 1. You should be able to do this on your own. 3 times 15 is 45. 45 plus 1 is 46. And since our area is in square centimeters, that means our length is going to be in centimeters. Next, I'm going to solve for our width. So our width was equal to 2x minus 5. Again, I'm going to substitute in my value of x. X is equal to 15, which means I'm going to replace my x value with 15 in brackets. So 2 times 15 is 30, and 30 subtract 5 is 25. And again, our units are in centimeters. As mentioned previously, if you subbed in the other x value, which was negative 77 over 6, and solved for the length and width, you would have gotten negative values, which doesn't make any sense in real life. That's why we only used one values of x. At this point, all we need is a concluding statement. So I'm going to say, therefore, the length is 46 centimeters, and the width is 25 centimeters. Again, the most important thing is to make sense of your x values as they relate to real life.